Hi guys, welcome to my channel First Byte Data Science, and today is my second episode of how to make code shorter, faster, and more efficient. And the idea is that I will code mathematically based on mathematical logic on real world applications that I set it up. And after that, I will try to make it shorter, faster, and more efficient, and try to make our coders feel more comfortable in writing our code based on RStudio. But if you guys use some other languages, the idea applies. The language is different, but the idea is the same. All right. And this is intended for basic and intermediate coders, not for professionals, of course. All right. So if you guys are interested in more video related to these topics or any other contents, feel free to subscribe and please like if you like these videos. And also in case that you have comments or you have something you want to share and you want me to solve in the future based on this content, feel free to comment in the comment section below. I appreciate every single comment and like. Okay, guys, so now we are at our studio. This is the second problem in the second episode. So today I'm going to share my research about cluster analysis. So one task that we need to do when we perform cluster analysis is to detect the number of groups hidden in the dataset. And I introduce an index to do that job, right? So now let's say we want to compute that index, right? For full detail about the index, you can see my paper on my website. But right now, I just want to focus on how to make code shorter, faster, more efficient. So what we're going to do is that, right? We want to compute, right, the index from 2 to n minus 1, right? So 2 represent groups, right? N minus 1 represent groups. We want to compare, right, the number of groups from 2 to n minus 1. I assume n is just 20, right? And I just build up this vector, right? I just make up this vector x, right? Actually, in the paper is something else, right? But it's a vector of length n, right? So what I'm going to do is that I will compute this index, which is this, right? This is the definition of my index, right? So the idea is this, right? We're going to see the improvement, right, of x from k minus 1 groups to k groups, right? We expect this guy to be big, right? If k is suitable. If k is suitable, this should be big. We compare this difference to the improvement from k to k plus 1, right? So if k is suitable, the top one should be big and the below one should be small, right? But the only problem is that what if there's no improvement at all, right? From k to k plus 1. So what we're going to get on the bottom is negative. So if you get something big here, right, on the top, and you get something negative on the bottom, what you're going to get is something big and negative, which is not our point, right? So if there's no improvement here, but the improvement is big, k is suitable, right? So what I'm going to do is that I adjust, right? I find the maximum between 0 and the improvement. So if the improvement is negative, I get 0. And the ratio is infinity, right? So for all the infinities that we get from this formula, I compare of them, right, by using some other factors for full detail in the paper. But the idea is this, right? I want to quote to compute the index from 2 to n minus 1. The easiest way is to just follow the definition, right? We compute each k separately in a for loop, right? We take the for loop from 2 to n minus 1, right? And we just plug in the formula, right? And just compute, okay? At the end, we get what we get, right? But as I mentioned in the first episode, that R is really good at handling vector and matrices. So what's the point of doing that, right? There's no point of doing a loop, right? What I do is that I reduce to only one line, right? So I compute the vector, right? For the top, right, I start from 2 to n minus 1. For the bottom, I do the vector again from 1 to n minus 2. I find the difference, right? I get a new vector of length n minus 2, right? On the below one, right, I do the same. Right? From 3 to n minus from 2 to n minus 1. I get a vector of length, the same length, n minus 2. And then I compare the whole thing with 0. I element wise with 0. All right. If some of the elements are negative, we take 0, right? So we get what we get and then we find the ratio. So we're going to get the whole thing of length n minus 2. And that's it, right? Okay. So now I'm going to show you guys, right, that the first one is slow, the second one is super fast, right? And you imagine if your n is bigger or your data set is bigger, right? That's going to be a lot, right? The difference is going to be a lot. But here you're going to see that the difference is just in terms of like sub-seconds, but it's fine, right? Just to, show that there's a problem inside. And if data is bigger than this, right, you're going to have a problem somehow, right? Okay, so let's try. So I'm going to do this, right? The whole thing and run the whole thing, right? And I record times again, like the first episode. And at the end, I will compare them. Okay. So I run, finish, right? Compare times, right? This guy, right? I get this, right? Which is the time for the first one, right? 0.005. And for the second one, we get 0.0003, right? So it's kind of like more than 10 times faster, right? And if we check the index, right, you're going to see that we get this exactly the same thing, which means our formula for the second one is correct because the first one we follow the formula closely in a loop. The second one we use a vector, right? And we can see that the results are the same, right? So it's good. In terms of plot, okay, this is the time for the first one, and this is the time for the second one, right? Okay, so as you can see, right, it's much better, right? If we handle our code by using vectors and matrices. Okay, so that's the idea of what I showed today, right? Okay, guys, so what I'm going to do next, as promised, is that I will show you guys whether or not ChatGPT can help us. All right, so what I'm going to do is that I will just copy this, right, into ChatGPT, right? I paste it here, right? I said the definition of my index is as follows. Okay. All right. And I say, okay, I want to, okay, let me add one more detail that my index depending on k is as follows. I want to compute, okay, my index from k equals 2 to n minus 1, right? And let's see if ChatGPT can do it or not. I believe that it can do it perfectly because this is just a simple problem. Okay, let's see. Okay, they have a summary of my index definition, right, which is perfectly correct. And then it provides our code. The first one is the version with a loop. All right, there's a version of a loop with a loop, and then this is a version without a loop, right? Which is exactly the same as mine, right? I break it into numerator and denominator, and then find the ratio, right? So it's exactly the same as my short version, and this is exactly the same as my long version, right? So ChatGPT can do what I did exactly correct with only this instruction. We don't need to provide any longer codes or anything, right? We just give the instruction, give the definition of the index, and ChatGPT can do it perfectly. I would have to say that this is a very simple problem, and that's why ChatGPT can do it perfectly. So next time I will try to make the problem harder and harder and harder, and let's see, at some point ChatGPT will not be able to solve it with a free plan. All right. Okay, guys. Um, to summarize, I have to say that I faced this problem before when I started working on my R package. And right now it's called Universal CVI, available on Cran. You may check it out if you are interested. And the thing is, at that time, right, I had to make my code practical. I need to make my package practical because I want to share to everyone. Because if someone has an old computer, you imagine if we work on very large data set. I show an example n equals 20 is super small, but in reality, you could have something like 20,000, you could have something like 2 millions. So it's impossible, right? If you have a loop like the first version. Okay. So the idea is that I have to make it practical for everyone, especially if someone work on very old computer. Okay. I hope that the content I share is helpful, and please like if you enjoy the video. If you are interested in more contents related to our language and data science, please subscribe to the channel and feel free to comment if you have something you want to share with us. I appreciate every single comment, and goodbye. See you in the next episode.